So now the thing here to notice is that we have a negative. Therefore, our velocity will also be negative for our from our acceleration, right? So if we are reducing acceleration into a stop, then we have to reduce speed as well. All right, so let's do that. So let's do this one first. That one. All those points have to be. It's gonna be a little messy, but I think we can decipher what I'm doing here. All right, so 3.25 times 0.25. 3.25 times 0.25, which is the delta t. All right, so that is 0.8125, so negative 0.8012. And remember, all this is negative. All right, 1.95 times 0.25. This is 0.487. Negative 0.487. All right, 1.15 times 0.25 equals, this one is 0.2875. 0.7, and is negative, don't forget the negative. Okay, negative 0.75 times 0.25, so a quarter of 0.75 is negative 0.187. Okay, then we have negative 0.5, a quarter of that is negative 0.127, 12.5, 0.275, or yeah, 275 times 0.25 equals negative 0.068. And then we have 0.105 times 0.25 equals negative 0.026. And then the last one is 0.03 times 0.25 equals 0.0075. All right, so in that case, we already have if you notice, we have the velocity and we have the acceleration, and we're finding them in terms of general values. In that case, what we need to do is do the same thing that we did before, which is try to find what is the average velocity, well, the points from that average velocity. So basically, let's go back to maximize this. Okay. So that plot right there corresponds to a plot where we basically have the delta velocity. All right, for the next step, let me remove this as well. For the next step, we have to go back to our book. And you're going to notice that we know this formula for average velocity. We have v2 minus v1 is equal to the integration of t0 to t1 or t1 to t2, whatever you prefer, of the acceleration with respect to time. Okay, so right now we have, well, before that, we can also have, let's go down here, we can also have something where we have v2 is equal to v1 plus acceleration from 0 to 2 seconds of acceleration times the delta t. So in this case, if we remove the acceleration term, you're going to be able to do this as a summation of delta t's. And then we have velocity. All right, so what we're going to do is we're going to take the velocity to the next the other side of the equation. Remember, delta v is v2 minus v1. But we want to take v2 to the other side of the equation because we're losing speed, we're losing velocity, but the velocity is actually a positive number. Okay, but here we have negative because we have it in our delta v configuration. If you notice, what we're doing right now is we're doing acceleration times delta t is our v2 minus v1. So the delta is negative. Delta v is negative, meaning that v1 is actually greater than v2. So what we want to do is find our velocity terms and in terms of our delta v. So for that, we're going to do our velocity number 1. Okay, we have velocity 2 from this delta, but we need to find velocity number 1, which is greater than velocity number 2. You'll see that in a minute. So this is meters per second. And at 2 seconds, we have 0. So actually, this is at 175. This value corresponds to 175. So let's start from 0. So that's good. All right, so the first thing we're going to do is we're going to start from 0. So 0 to 0.7 is, we're going to take positive now because we're on the other side of the equation. So you'll see this in a minute. Just remember to do this when you have to find your average velocity. All right, the next term is, we're going to have to use your calculator again. And it's as follows. So 0 0.7, 0 0.7, so 0, well, actually it's here on the calculator side. 0 0.007 plus 0.26 equals 1.267. Okay. Next one is 0.27. This is going to be plus. I apologize. I did it wrong. So it's 0.7 plus 0.026. All right. Sorry. So this is 23. All right. Yeah, that looks better. All right. Plus 0.068 equals 0.101. Notice that all this is positive now. Plus 0.125 equals 0.226 plus 0.187 equals 0.413 plus 0.2875 equals 0.7 plus 0.387 equals 1.187 plus 0.812 equals 0.999. Okay, so 2. All right, so let's look at this. Now, this velocity is actually the one that we are going to plot. So just to be able to see it better, I'm going to use this plot here. All right, so if you notice, let's put it here for a second. Okay, so at 0, we have to be 0, right? Because it's coming to rest, which is 0 value right here. All right, so at 2 seconds, we're at 0. And actually, if I did my table correctly, this 2 needs to match with those. All right, because now we're doing deltas. So the delta, I need to do another table. The delta would be always 0.25, but okay, you see my point. So let's see this. At 2 seconds is 0, or we can start from 0 seconds. So at 0 seconds, which we do start from 0, so that's good, is 2 meters per second. At 0.25 is around here, we're saying is 1.2, 1.18, then at 0.5 is around 0.7, 0.75, etc. So we're building the curve, and it's positive. So this is a very powerful tool, and I want you to understand this. I need you to see this concept. The delta is negative because the delta, we just mentioned that, is V2 minus V1. So V2 is this guy, is the one at time step ahead, and V1 is greater than V2. So the delta V is a negative value. Okay, that's why this negative value is here. Now this is positive and decreasing because the velocity is decreasing positively. So you're going from 60 miles per hour to 0. You're going, remember, velocity is a vector with a direction. So you're losing velocity. You have a negative sign because the magnitude is decreasing. Okay, so the velocity, even though the numbers are positive, is decreasing. That's why your delta is negative, but your velocities are positive. Okay, so that is pretty much how you find the velocity. If we wanted to find the distance, it will be the same story. And actually, we can do that right now. Let's take that and this together. See if we can get all these objects together. I was not able to bring them together, so instead of grouping them, I'm just going to continue my table. All right, so what we want to do now is, with that graph in mind, we're going to find the average distances.